we are given that a battery manufacturer guarantees that mean reserve capacity of a certain battery is greater than 1.5 hours. To test this claim, you select 50 batteries and find the mean reserve capacity to be 1.55 hours. It had been previously determined that the population standard deviation is 0.32 hours. If alpha, this is the level of significance, if alpha is 0.01, is there enough evidence to support the claim? This alpha is telling us the level of significance. And if it is 0.01, we are talking about 1% level of significance. Now, to look through the question and see what do they want us to use. A battery manufacturer guarantees that mean reserve capacity of a certain battery is greater than 1.5 hours. To test this claim, you randomly select 50 batteries and find the mean reserve capacity to be 1.55 hours. That had been previously determined that the population standard deviation is 0.32 hours. So that means they are forcing us to use a z-statistic. This is a z-statistic. Why? N is greater than 30 because they are telling us there are 50 batteries. 2, standard deviation equals 0.32 and is known. Of course, that's what we are saying. The standard deviation of the population is known. Now, they are saying the mean is found to be 1.55, okay? But later on, before that, the company was saying our reserve capacity of the battery is greater than 1.5 hours. So we have to test this claim for the company manufacturer, for the battery manufacturer. If he is claiming that the reserve capacity of the battery is greater than 1.5, then we need to use this information given to us and be able to either accept his claim or reject his claim. So first of all, we are going to state the hypothesis. So the null hypothesis is that the mean is equal to 1.5. And the alternative hypothesis, here they are saying the mean is greater than 1.5 hours. So that means our null hypothesis should be our mean is equal to 1.5 hours. Then the alternative hypothesis will be the mean is greater than 1.5 hours. So what does this call us? This is going to be a one-tail test. And this is the right tail test. So let's look for Z. So z-statistic, Z is equal to the sample mean minus the mean of the hypothesized mean, or the mean of the population that we already have, and we divide this by the standard deviation divided by n. First of all, we are told that n is equal to 50. The mean, the hypothesized mean. Let me write it here. This is the hypothesized or the hypothetical mean against which we have to make the test of this claim. Then nu, of course, we know this nu is 1.5. Then the standard deviation is 0.32. So we can get Z, which is equal to the sample mean we are told that when they did a sample of 50, the mean was found to be 1.55. So this is going to be 1.55 minus the 1.5, then divided by the standard deviation, which is 0.32, divided by square root of 50. So that value 1.55 minus 1.5, we divide it by 0.32. Then we multiply by root of 50. So my z value is equal to 1.10. That's what we are getting. So what we do, we are going to look for the critical value of z. So this is the calculated, this is the calculated z. Calculated z is 1.10. So let's move and look for the critical value. So to get the critical value, we are going to draw our normal distribution curve, and then we are told that we are looking at a level of significance of 1%, and that is 0.01. So our alpha is 0.01. That is our alpha, meaning this other side is 0.99. Now, what is here is the z critical value. We are going to look for that z critical value, the value of z that corresponds to 0.01. So what is that value of z? So let's check in this table of z values, okay, and the proportion or the area under the curve. Here we are looking at the area to the left of this z value. So we are going to go down and look for a value that corresponds to the probability of 0.01. 0.01 is around here. So 0.01. So 0.01 is going to be corresponding, is going to correspond to, let us check if we have, okay, so the 0.01 is around here, this is 0.1. What is our level of significance? Let's change our level of significance to 0.1. Okay. So let's change our level of significance to 0.1. I think that was an error. So from there, we make this 0.1. So that is 0.1. So we come here and look for the value that corresponds to 0.1. So I can see the 0.1 is approximately equal to 0.10027. So I can take that value, and this value, I have 0.08 there, and it is on the row of negative 1.28. So what we do, we take, this is negative 1.2 plus negative 0.08. So this is negative 1.28. So I come here and get my negative 1.28. Okay. So if that is, this is a negative 1.28, but it is supposed to be this other side. So this is negative 1.28. Then this is, as I told you, if you read the 1.28, it means that negative is always on this side. Because we have a 0 here, and values below 0 are negative, values above 0 are positive. That's why I'm going to make this positive 1.28. After all, if I looked for the probability that corresponds to 0.9, it is going to be 1.28. If maybe you want to confirm that, you can go and confirm. We can check on our table. So let's look for 0. The z value that corresponds to 0.9, for example. Come and check. So around here, so you can see 0.89973 is approximately 0.9. So you can see this 0.9 corresponds to 1.2, then plus this 0.8, and that would be 1.28, corresponds to 0.9. And that 0.9 also corresponds to an alpha value of, or the level of significance of 0.1. This is, for example, this can be like the confidence interval from 0 to 90. That one is okay. But if we go to now 0.1, then that is a point where we shall be rejecting the null hypothesis. So if I take 0.9, the z value will be 1.28. And then that will tell you that obviously we are right to say that a z value that corresponds to 0.1, okay, alpha being 0.1, or that is 10%, is negative 1.28. Then this other value is 1.28, which is positive. So I'm going to compare my value of 1.1. So compare, I will see that the calculated value, the z statistic, is actually less than the z critical. So what does that mean? If this is a rejection region, this is the rejection region, and we are beginning from 0, we go to 1 before we reach 1.28, then z calculated is outside the rejection region. So z calculated is outside the rejection region. So if it is outside the rejection region, we therefore fail to reject the null hypothesis. So here, this is going to tell us that there is sufficient evidence. There is sufficient evidence. Okay. Okay, here they are telling us the value is greater than 1.5. So we can see there is no sufficient evidence to support the claim. So we shall say no sufficient evidence to support the claim. And therefore, we will have answered this problem. Because the question was, is there enough evidence to support the claim? If the null hypothesis was rejected, if we could reject the null hypothesis, then we could say there is enough evidence to support the claim. But since according to what we are seeing, the null hypothesis is true that the mean is about 1.5, it is not greater than 1.5, then we fail to reject the null hypothesis, and then that means we adopt the null hypothesis, and there won't be any evidence to support this claim that the mean is greater than 1.5.